Time for a review of PPP, and then we're going to take a very quick look at PPP over Ethernet. And we're going to start here with this link between routers 1 and 3, 172.12.123.1 on router 1 side, .3 on router 3 side. Now, the first thing you learn really about a link like this, or any serial interface on a Cisco router, is that even though in your CCNA and your CCNP and your future studies, we use PPP pretty often. We use frame relay maybe a little more often, but the default encapsulation is one you're likely not to stick with in a lab or in a production network, and that is HDLC. And I've got show interface serial here verifying that encap type. And all you do to change that is change it with the encapsulation command. And I can bring up the live equipment here as well. Let me do the tighten up there and get that over there. And you can see encap question mark, and we've got frame relay HDLC, the point-to-point protocol. Some others there you may be familiar with, but they're outside the scope of the exam, so we're going to stick with PPP for right now. So let's head back to the board here for just a moment. I just did a quick verify. And of course, you're going to do that with the encapsulation type change. You have to do that on both endpoints. What am I going to see as far as serial 1/0 is what, line protocol is what, if there's an encapsulation mismatch? What am I going to see there? I would actually see, and I can do it here, slightly different interface, but the same result, where I have up and up right here, which of course is always what we want. If there's an encapsulation mismatch, we've got PPP on one side, frame relay on the other, you're going to see the physical state of the interface, in this case 0010, remain up, but that line protocol, the logical state of the interface, will of course then be down. So I've already done the PPP encap here on the live equipment. And before we take a look at our authentication options, why do we switch from HDLC to PPP to begin with? Well, the authentication options I just mentioned are one big reason why. PPP offers authentication options in the form of PAP and CHAP, which we'll look at here in a moment. Also some vital error detection and error recovery features. HDLC doesn't have any of those, so in today's world we tend to not use HDLC. Now, we have here PAP and CHAP, the password authentication protocol versus the challenge authentication protocol. And with PAP, PAP is kind of like walking up to a sleeping security guard and tapping him or her on the shoulder to wake him up and then say, here's my pass, can I come in? And in this case, if router 1 is authenticating router 3 and we're using PAP, it's very passive authentication. That's not what the PA stands for, but it probably should. Because router 1's just sitting there, not just minding its own business, and then router 3 comes up and says, here's my password. Where with CHAP, we're going to see an active challenge. Router 1's basically saying, who the heck are you? And router 3 breaks out its credentials and says, here's who the heck I am. Now, I want to show you this config, and we're going to look at this on the board because I want you to see a couple of debugs side by side. And you've probably already guessed which ones, but in case you haven't, you'll be surprised. And of course, you'll see we couldn't really do these at the same time, but I want you to see them side by side. The first thing we've got to do, though, of course, is set up a username password database. And two of them actually, if we have each router authenticating the other. We could just have router 1 authenticating router 3 or vice versa. Each authentication is a separate operation, but in these configurations I have two-way authentication set up. Router 3 has a one-line database containing router 1's name and password, CCNP, and router 1 has a one-line database containing router 3's name and password, which again is CCNP and not something I would ever do in a production network, of course. Now, CHAP, we're going to put that on the interface with PPP authentication CHAP. And what I did is I ran debug PPP authentication on router 3 before I finished this config. Because it's one thing, if you're troubleshooting PAP or CHAP, it's probably just a mistyped password. Just being blunt, most of the time it's going to be mistyped password. Maybe you got a null space snuck in there, but you can go blind just staring at the config. You really can, because you can stare at the config and say, I don't see what's misspelled about this word. But if you know these debugs, it's going to give you a real hint as to where the issue is. In this case, we didn't have an issue, but what we did have is two challenges, two responses, and two successes. And of course, those two successes, that's what we really want to see. And what we do see with the debug, this particular one, is a challenge from each router, a response from each router, and then success. And notice the O and I there letting us know whether the message is outbound or inbound. Now, the reason I wanted to show this to you on the board is I wanted to show you debug PPP authentication when PAP is used instead. So I just took CHAP off, put PAP on. The authentication went fine, but notice in this second debug output, there are no challenges. We just see a couple of incoming messages, a couple of outgoing messages. There's one in the middle about, hey, I'm authenticating that peer router 1. And, it's all fine. So, of course, many years ago, you would look at this and say, well, I don't really see the big difference. Who cares? Well, in today's world, there's really just not much room left for PAP because PAP sends both the username and password out in clear text. And in today's world, that's just totally unacceptable. The only place you're really liable to see PAP is on your CISCO certification exams because, frankly, there's not a whole lot of room for it in today's real-world networking. Now, a word here about the kind of link that I used, and maybe a small history lesson while we're at it. I'll keep it brief, I promise. Now, here I used PPP over a point-to-point serial link, and that's likely how you saw it in your CCNA studies. But that is not the only type of link that can use PPP. We do still have dial-up access links out there, folks. We can't act like they don't exist. There aren't as many as there used to be, but they're still out there. And anytime you have a dial-up link, you have two big questions. Under what circumstances is that call going to be placed to begin with, and how long will the line stay up? There's a protocol, a CISCO protocol, actually called ISDN, and it's long gone from the CISCO exams. But what was happening is that one router literally called another router. And of course, whenever you have something like that, you do have to have the same considerations. You have to have rules. When is router A going to call router B? How long will the link stay up? Other things like that, because you don't want just the link going up and staying up. That's not real efficient, and it could get real expensive. Now, with dial-up links, what we did with ISDN and what we do here with these dial-up links is define what we call interesting traffic, and it's yet another use for ACLs. Interesting traffic is the term used to describe traffic that can bring up a dial-up link, not just traffic that can cross it, but traffic that can actually cause the dial-up link to be dialed, to be created. Now, you have to define the amount of time the link can stay up in the absence of interesting traffic, and you're all set. Which, of course, one solution in networking leads to another question. And the question is, well, what if I don't define any interesting traffic? Can I have the link brought up without it? Can I keep it up? And you can with something called dialer persistent. I love that name. I'm not sure why. It's just so unique. Dialer persistent. And the thing is, it sounds like something that's just going to keep calling until it makes a connection. That's not really it. The link itself is persistent. It's going to stay there. Again, I'm sorry it's really way beyond the scope of the NP route exam, or we'd definitely dig into it. I like working with interesting traffic, but then again, I liked ISDN, and I was the only one. So instead, let's talk about PPP over Ethernet for just a moment, and why in the world I would want PPP to go out over Ethernet. Why would I do that to begin with? Well, it's a combination of PPP and Ethernet, duh, I know, but it's used primarily by ISPs. And PPP, what happens is it's actually encapsulated inside an Ethernet frame, and that allows transmission over any Ethernet-friendly interface. And I have a line here for you from Cisco's website about PPPoE clients are typically personal computers connected to an ISP over a remote broadband connection, such as DSL or cable service. ISPs deploy PPPoE because it supports high-speed broadband access using their existing remote access infrastructure. They like that part. And because, here's the part we like, it is easier for customers to use. And we will take customer ease of use anytime we can get it. Again, it's one of these topics that is just touched on in the CCNP route exam, but I do want you to know what the phases of it are. The first phase of a successful PPPoE session is the active discovery phase, which leads to the question, what is being actively discovered? Well, this is when your client is looking for a PPPoE server. And once that happens, we're off to the session phase, and you can guess what happens there. That's where your PPP authentication and negotiation take place. Again, I wouldn't use PAP if I were you. When that phase is complete, our L2 encapsulation is now in place, and data can go over the link. Obviously, it gets a little more complex with that at the ISP level, but that's fundamentally how PPP-oE works. That concludes our look, actually our review and our look at PPP. And coming up next, we're going to do a routing operation review. We're going to do some walkthroughs of some routing fundamentals, and then after that, we'll start digging into some advanced EIGRP and OSPF coming up soon. I'll see you on the next vid.